Hello, I am Sujit. Welcome to Physics 2020. So today we are going to discuss the topic that is relative velocity in two dimension. So the continuation of that topic, that is relative velocity in two dimension. In relative velocity in two dimension, we have two topics, that is Riemann problem and riverboat problem or river simmer problem. So already we have discussed in Physics 2020, we have discussed the theory and the concepts of Riemann problem, and 10 or 11 numericals we have discussed in this topic, that is Riemann problem. So please go and watch that topic. It is a very important topic. Different numericals you can expect from that topic. Even in Jeemains or Neet, you can expect that is different problems from that topic. So the next topic in relative velocity into dimension is river simmer problem or riverboat problem. So first we are going to discuss the theory of, that is first we have a discussion about, that is what is relative velocity. We have to understand the concepts of relative velocity. So in Physics 2020 already we have discussed, that is relative velocity in one dimension. So we have two sections of, that is conceptual section and two problem section we have discussed, and nearly 10 numericals we have solved in that topic, that is relative velocity in one dimension. You go and watch, that is, my dear students. If you want to clearly understand that is relative velocity means, go and watch, that is motion in a straight line. In Physics 2020 there is a playlist called motion in straight line. In that playlist you can you have a video, that is relative velocity in one dimension. So after understanding that the relative velocity in one dimension, we can go to this relative velocity in two dimension, that is a riverboat problem or river simmer problem. So anyway, before starting this riverboat problem or river simmer problem, we have a short discussion of that what is a relative velocity. Okay, come on. So relative velocity in 2D. Relative velocity in 2D. That is, in that we are going to discuss, that is a Riemann riverboat. Okay, riverboat or river simmer problem. River simmer problem. So first we are going to discuss what is relative velocity. Okay, relative velocity. Relative velocity. So concept 1, first concept 1. Concept 1. So consider a train. Okay, consider a train. This is a train. Okay, this is a train. So a passenger is sitting. A passenger is sitting inside the train. So P, passenger. Okay. So the train is moving with a velocity, that is V T. It is 10 meter per second. 10 meter per second. So this is a platform. Okay, platform or ground. Ground. A man is sitting in the platform. A man is sitting in the platform. So he is the observer. Okay, observer. So what is the velocity of the passenger with respect to this observer we have to find. So come on here, velocity of the Vt, velocity of the train with respect to the ground, that is 10 meter per second. That is, when the man in the platform watches the train, so he feels that the train is moving with 10 meter per second. So that's why I am writing velocity of the train with respect to the ground. Okay. So velocity of the passenger, okay, velocity of the passenger with respect to the train, velocity of the passenger with respect to the train, Vpt, velocity of the passenger with respect to the train, that's equal to 0. So when the observer sees that, he feels that if the passenger is also moving, the train is moving with 10 meter per second, so the passenger is also moving with 10 meter per second. So when the observer is inside the train, okay, inside the train, and he watches his observer, that is, the passenger is there, the observer is also sitting near the passenger, and he sees the passenger, that is, the passenger is at rest, the passenger is not moving. Okay, not moving. So Vpt, velocity of the passenger with respect to the train. Okay, so the observer is also sitting inside the train. Okay, inside the train. And that's equal to 0 meter per second. Okay, 0 meter per second. So we have to find velocity of the passenger with respect to the ground. So what is the velocity of the passenger as seen by the man or observer in the ground? We have to find that. Okay. So this is case 1 in concept, that is case 1, that is passenger sitting inside the train. Inside the train. First case. Okay, so understand that velocity of the train with respect to the ground is 10 meter per second. Velocity of the passenger inside the train, that is equal to 0. So we have to find, that is, velocity of the passenger with respect to the ground we have to find. So relative velocity formula, that is velocity of the passenger with respect to the train is equal to, what is the formula? Velocity of the passenger with respect to the ground minus velocity of the train with respect to the ground. Okay, with respect to the ground. So from this we have to find that. Okay, so we have to find that is velocity of the passenger with respect to the ground. So velocity of the passenger with respect to the ground is equal to velocity of the passenger with respect to the train plus this one comes this side. So plus velocity of the train with respect to the ground. So that's equal to velocity of the passenger with respect to the train, that is 0, plus velocity of the train with respect to the ground, that is 10. So that's equal to 10 meter per second. So plus, okay, plus. So what is the feeling? So the train is moving 10 meter per second. So the passenger is sitting inside the train. When the observer outside the train or sitting in the platform, so observes that he also, that is, he feels that the man is also moving with 10 meter per second. So the positive sign indicates that he is also moving in the rightward direction. So the velocity in the rightward direction is taken as positive. The velocity in the negative leftward direction is taken as negative. Okay, so that is the feeling. So when the passenger sitting in the platform, so observes that, so he feels that the man is also moving with, the train is moving with 10 meter per second. So the passenger sitting inside the train is also moving with 10 meter per second. So velocity of the passenger as seen by the ground. As seen by the ground means as seen by the observer in the ground. is equal to, so we are getting that is 10 meter per second. So this is case 1. Okay, so what is case 2? So next one, concept 1. Okay, concept 1, case 2. Case 2. So this is a train. This is a train. So the train is moving, that is velocity of the train is equal to 10 meter per second. 10 meter per second. So the passenger inside the train is running inside the train. Okay, inside the train, he is running in the rightward direction with a velocity of that is 4 meter per second. 4 meter per second. Relative to the train, that is very, very important. Okay, relative to the train. So second one, passenger is running inside the train. Inside the train. Okay. So the passenger is running, that is P. Okay. Inside the train with a speed of 4 meter per second in the rightward direction. Relative to the train, that is very, very important. Okay. Relative to the train. Relative to the train. So what is the meaning? So the observer is sitting inside the train and watching. So he finds that, so the passenger is running inside the train with a speed of 4 meter per second. So the train is moving with that is 10 meter per second. Okay. So we have to find that is, what is the velocity of the man or velocity of the passenger as seen by this observer. So here also the passenger, it is a platform. So the observer is sitting in the platform. So when he finds that, okay, when he observes that, what is the velocity of this passenger with respect to this observer. So velocity of the passenger with respect to the ground, we have to find that. Okay. So here, what is this Vt actually? So Vt means velocity of the train with respect to the ground. With respect to the ground. So that's equal to 10 meter per second. So what is this? Velocity of the passenger with respect to the train. Okay, train. So that's equal to 4 meter per second. Okay, 4 meter per second. So relative velocity formula. So velocity of the passenger with respect to the train. Okay, with respect to the train. So this is also vector. Okay, vector. So is equal to velocity of the passenger with respect to the ground minus velocity of the train with respect to the ground. Clear? So from this we have to find velocity of the passenger as seen by this observer. So V Pg is equal to V Pt, okay, plus V Tg, okay, Tg. So that's equal to, what is Vpt? So that is 4 meter per second, okay, 4 plus, what is Vtg? That is 10, okay, 10. So that's equal to 10 plus 4, that is 14 meter per second, okay, 14 meter per second. So this is positive. So what is the feeling? What is the feeling? So the train is moving with 10 meter per second. So the passenger inside the train, he is also running with 4 meter per second. So when the observer sitting in the platform observes that, so the passenger is moving inside the train with a speed of 14 meter per second. Okay, 14 meter per second. So understand the situation. So the train is moving with 10 meter per second. So the passenger inside the train is moving with 4 meter per second. Okay, 4 meter per second. That is, when the observer is sitting inside the train, he feels that the man is running with 4 meter per second. When the observer sitting outside the train, that is in the ground, ground, he feels that the passenger is moving with 14 meter per second in the rightward direction. Okay, rightward direction. So this is case 2. What is case 3? Case 3. Case 3. Case 3. Passenger is running inside the train. Case 3. Passenger is running inside the train with a speed of running inside the train leftwards. That is the next case. Okay. Right. So he is the passenger. He is inside the train moving with, that is 14 meter per second. Okay, 14 meter per second in the leftward direction. Okay, leftward direction. So 14 meter per second in the leftward direction relative to the, that is very, very important, relative to the train. Okay, so we have to find what is the velocity of the passenger. Okay, velocity of the passenger as seen by the ground. Okay, as seen by the ground, we have to find that. Okay, fine. So come on. So the train is moving with 10 meter per second. That is the velocity of the train as seen by the ground. Okay, velocity of the train as seen by the ground is equal to 10 meter per second. 10 meter per second. Velocity of the, so this one 14 meter per second. Velocity of the passenger with respect to the train. So the train is sitting, that is the observer is, when the observer is sitting inside the train. Okay, inside the train. So his speed is 14 meter per second in the leftward direction. So leftward, that is sign convention. So minus 14 meter per second. Okay. So what is the formula? We are writing, that is velocity of the passenger with respect to the train is equal to velocity of the passenger with respect to the ground minus velocity of the train with respect to the ground. Okay, so that's equal to velocity of the passenger. So we have to find from this velocity of the passenger with respect to the ground, we have to find out velocity of the passenger with respect to the ground is equal to velocity of the passenger with respect to the train. Okay, train minus, so plus velocity of the train with respect to the ground. Okay, so that's equal to, what is velocity of the passenger with respect to the train? Minus 14 meter per second. Minus 14 meter per second, sorry, minus 14. Okay, minus 14 plus velocity of the train with respect to ground, that is 10. So that's equal to minus 14 plus 10. So minus 4 meter per second. Okay, minus 4 meter per second. What is the feeling? So what is the feeling? So the train is moving with 10 meter per second and the passenger inside the train is moving with 14 meter per second in the leftward direction. So the train is moving with 10 meter per second. So the passenger inside the train is moving with 14 meter per second. So when the observer is sitting inside the train, he feels that, so the passenger is moving in the leftward direction with the speed of 14 meter per second. When the observer in the ground frame, okay, sitting in the platform and watching, so he feels that, so come on, that is velocity of the passenger with respect to the ground. We are getting minus 4 meter per second. So the minus sign indicates that it is moving in the leftward direction. So the passenger inside the train is moving in the leftward direction with a speed of 4 meter per second. Okay, 4 meter per second. Actually, he is inside the train, he is moving with the 14 meter per second. When he is watcher in the ground frame, okay, ground frame, the man or the observer in the ground feels that, okay, feels that he is moving with the 4 meter per second in the leftward direction. Okay, leftward direction. So understand. Okay, so this is the case 3. So in relative velocity, 3 cases we have discussed. Man at rest in the train. So man is moving in the rightward direction, man is moving in the leftward direction. Okay. Concept 2. Concept 2. Concept 2. So consider this is a train. So we have to passenger running inside the train in different direction, in different direction. Different direction. Okay. So consider this is a train, it is moving with that is speed 8 meter per second. Okay, 8 meter per second. So consider this is a passenger inside the train. Okay, inside the train. So he is moving inside the train or running inside the train in this direction. Inside that. So that is with 6 meter per second. 6 meter per second. So 6 meter per second relative to the train. Relative to the train. Okay, relative to the train. So the train is moving in this direction. So the passenger is, in the initial case we have discussed, the passenger is moving inside the train either in the rightward direction or leftward direction. So here, so the passenger is moving inside the train in this direction. Okay, in this direction. So we have to find what is the velocity of the passenger. So he is the passenger P. So velocity of the passenger with respect to the ground we have to find out. Okay, passenger find out. So come on, from the data given, so what is 8 meter per second? What is 8 meter per second? Velocity of the train with respect to the ground. Okay, velocity of the train with respect to the ground is 8 meter per second. Velocity of the passenger, okay, velocity of the passenger with respect to the train, okay, with respect to the train is equal to, that is 6 meter per second. Okay, 6 meter per second. So we have to find velocity of the passenger with respect to the ground we have to find out. So come on, velocity of the passenger with respect to the train, relative velocity formula. So that's equal to velocity of the passenger with respect to the ground minus velocity of the train with respect to the ground. Okay, so from this we have to find velocity of the passenger with respect to ground, we have to find out. So that's equal to velocity of the passenger with respect to the train plus velocity of the train with respect to the ground. So the addition of these two vectors. Okay, so the addition of these two vectors. In the previous cases also, the addition of these two vectors, that is v velocity of the passenger with respect to the train, velocity of the train with respect to the ground. So we have added. So here the problem is, that is velocity of the passenger with respect to the train. So it is acting, this vector is acting in this direction. In this direction. So another vector, velocity of the train with respect to the ground, it is acting in this direction. Okay, so this is v pt and this is v tg. Okay, so the two vectors, they are acting in the that is straight line, means that is using sign convention we can add, that is velocity of, that is the way the vector acting in the same direction or a different direction in the straight line. So here it is a different case. So one vector is acting in this direction and another vector is acting that is perpendicular to this vector. So how we can add these two vectors? So we can use, that is parallelogram law of vectors. Okay, parallelogram law of vectors. So what is the resultant of these two vectors? So the resultant of these two vectors is in this direction. This direction. So this is what? V P G. Okay, V P G. Okay, V P G. So clear? So this direction. So this is the resultant. Okay, resultant of these two vectors. So addition of these two vectors give this vector. Okay, V Pg. Okay, so Vpg is equal to Vpt plus Vtg. So what is the, so this vector has both magnitude and direction. Okay, magnitude and direction. So this, it makes an angle theta. It makes an angle theta with the horizontal vector. Okay, horizontal vector. So Vpg. So this is a vector addition. So what is the magnitude of this vector? Okay, magnitude of this vector. So modulus of Vpg is equal to square root of, am I right? Square root of Vpt square plus Vtg square. So A vector, B vector, which are inclined at an angle theta, So what is the resultant? A square, square root of A square plus B square plus 2AB cos theta. Okay, 2AB cos theta. So here theta, what is the angle between these two vectors? 90 degree. So cos 90 becomes 0. So that term becomes 0. Okay, so Vpt square plus Vtg square. So that's equal to, square root of Vpt. Okay, Vpt. So it is 6 meter per second. So 6 square plus Vtg. So it is 8. So 8 square. Okay, 8 square. So that's equal to square root of 36 plus 64. So that's equal to square root of 100. So is equal to 10 meter per second. Okay, 10 meter per second. So what is the feeling? So the train is moving with 10 meter per second. Okay, 10 is 8 meter per second. So the passenger inside the train is moving in this direction 6 meter per second. Okay, 6 meter per second. So come on. So this is 6 meter per second and this is 8 meter per second. Okay, 8 meter per second. So the passenger is moving in this direction. Okay, in this direction. So with the speed of, so what is the speed of? 10 meter per second. Okay, 10 meter per second. So the observer in the platform feels that the passenger is moving in this direction. So the observer inside the train finds that so the passenger is running in this direction. So the passenger in the platform observes that the observer is running in this direction with a speed of, that is 10 meter per second. Okay, 10 meter per second. So let theta be the angle. So in what direction he is moving? So the passenger is moving. So the horizontally the train moving. So in which direction the passenger is moving? According to this observer. According to this observer. So what is the formula? Yes, tan theta is equal to, come on, tan theta is equal to, tan theta is equal to opposite side. Okay, opposite side, that is 6 divided by adjacent side, that is, this is 8 meter per second. Okay, 8 meter per second. So tan theta is equal to 3 divided by 4. So theta is equal to tan inverse of 3 by 4. So 3 by 4. So 3 by 4 is a famous triangle. Okay, famous triangle. 3, 4, 5. So this is the which angle? That is 37 degree. Okay, 37 degree. 3 opposite side, 4 adjacent side, hypotenuse 5. Okay, 5. 3, 4, 5. Okay, so that's a famous triangle. So theta is equal to 37 degree. Okay, theta is equal to 37 degree. So what we can say? So according to the observer sitting in the platform, okay, sitting in the platform, feels that the passenger is moving 37 degree with the horizontal. Okay, 37 degree in the horizontal. So this is a concept. Okay, that is a relative velocity. So the passenger inside the train feels that he is moving in this direction. So the passenger in the ground feels that. So the passenger is moving in this direction. That is 37 degree with the horizontal with a speed of 10 meter per second. Okay, 10 meter per second. Clear? So this is relative velocity. So this is the most fundamental of that is relative velocity. So this concept we are using, that is a Riemann problem. That is river board problem or river simmer problem. So the river is moving in this direction. The simmer is running. Simmer is swimming. Okay, in the river in this direction. So this is the resultant speed and direction of the simmer. So from this we will discuss the concept of that is river simmer problem or river boat problem. So this is the most fundamental of that is what a river boat problem or river simmer problem. Okay, so with this we will wind up this session. So in the next section we will come with that is the concept or theory of river boat problem and river simmer problem. Bye.